Ladies and gentlemen, it's a fireside chat, and may I please invite our moderator first, Ms. Rashmi Guru Rajarao from Manilo Design, who's joining us. Ladies and gentlemen, please put your hands together for her as she joins us to be the moderator for this chat. A very good afternoon. Thank you. Tooling opportunities and challenges in the aerospace industry. For this, may I please invite Mr. Venkatesh Mudragalla, co-founder and COO, J Aerospace. Ladies and gentlemen, let's put our hands together and welcome him for this fireside chat. I'd like to now hand over the stage to the both of you. Thank you.
Hi everyone, good afternoon, and thank you Tagma for this wonderful opportunity, and it's my honor and privilege to share this stage with you, sir. So during the presentation yesterday, one of the facts that came out was 60% of the tooling is targeted towards automotive, and maybe around 20% is for aerospace. So in that context, I want to begin by asking you, what do you see as the unique, requirements of tooling when it comes to aerospace versus, let's say, an automotive industry?
Yeah. So thank you. Before I get into answering the question, so good afternoon, gentlemen, ladies and gentlemen. Thank you, Tagma and Nishant, for giving this opportunity and having me here, and thank you, Rashmi, for doing this. So just to get to the question, I think if I look at it at a very high level, see, the machine and the kind of tools that we do are very, very similar. However, I think if I were to give a very high-level answer, the mindset is what makes a real difference. That's a generic answer. But if you get into specific details, there are 3-4 unique features that I will look at in aerospace tooling when compared to automotive tooling. Firstly, if you look at, as we understand, for example, if Tata Motors or a Mahindra makes a car, the volume of cars run into thousands every month, right? Whereas if you look at in the entire industry, the total number of aircrafts that are produced in the world are less than 1,500 aircrafts in the year. So the volumes are very starkly different. So which means the efficiencies and the repeatability, the scale that you get in automotive industry, you don't get that in the aerospace industry tooling. That's number one. Second thing, while every industry has its own complexities, one thing that we see at a generic level in aerospace industry is the tolerances are much tighter when compared to the automotive industry. While in automotive industry, we talk about tenths of mm, here we talk about microns. So there's a difference in terms of tolerances. Third and most importantly, the requirement in terms of documentation. And traceability is very, very high when compared to automotive industry. See, at the end of the day, while tooling is not flying components, but still it's as critical as a flying component. So the documentation and the traceability requirements are pretty high in the aerospace industry when compared to automotive. So these are 2-3 things that I think which will differentiate from a tooling perspective when you look at automotive and aerospace industry.
Yeah, so somewhere I've heard that, the weight of the component is as much as the weight of the documentation in aerospace. So, yeah.
Very true.
So, which brings me to the second question, in terms of challenges, when you are working with the aerospace, tooling, what are your biggest challenges, whether it is cost, precision, timeline, or even supplier reliability?
So, I think before I get into challenges, I think we have been able to accomplish quite a few things at the tooling level in India. Of course, we heard gentlemen talking in the session in the morning where the kind of work that we have been able to do in tooling in the automotive sector. Having said that, even in the aerospace industry, we have been able to do significant amount of tools. I mean, I myself in my previous roles and what we are doing right now, we have delivered thousands of tools from India's ecosystem for many global programs, both defense and commercial programs. Now, if you look at the challenges, what are the kind of challenges that we are struggling with? Even today, I think our ecosystem maturity in terms of delivering aerospace tooling is quite limited. If I were to bluntly put it across, our say-to-do ratio in terms of the timelines that we deliver, our compliance to some of the requirements, our compliance to certifications, etc., is still considered to be relatively low. See, we come also from a point of disadvantage because anytime a global manufacturer is actually procuring something from India, they look at it from a completely different lens. which in a way acts as a disadvantage to us, but that's also something that we see as an opportunity where we can improve and start doing better. So those are my inputs on that. Yeah.
Great. So coming to the opportunities, everybody is talking where India's share in aerospace manufacturing is increasing, right? So for you, what comes to you as the biggest opportunity for localization, especially from a point of view of startups and MSMEs?
See, I think this is one of the best times to be in the aerospace industry. I think we see a lot of tailwinds for aerospace industry in the country. If I were to give you a macro picture, today in India, we run the number of aircrafts in India are almost 1/4 of aircrafts that are run in China with equal amount of population. While we see this as a difference, I see a very big opportunity. We believe the number of aircrafts that are going to get deployed in our aviation ecosystem will keep going up as we move along. So there is a natural gravitas for work also to move to the place where the requirement is generated from. So we see a lot of manufacturing moving in from Western economies to India. Second thing, one distinct advantage that we have in India is availability of strong talent pool. Today, where a lot of manufacturing happens even today in the aerospace industry in the Western economies. If I were to put some numbers, even today more than 80% of the manufacturing in the aerospace industry happens in the Western economies, which is US and Western Europe. Today, they are struggling with some of the challenges like severe labor shortage, talent attrition, so they don't have people to do this. So that's where India presents as an opportunity itself. We have a large talent pool. We add close to 1.5 million engineers every year into our workforce. We have more than 50 million people that we add into our workforce. However, some of this talent is raw. It's not industry ready yet. Of course, we have to take steps. How do we bridge that gap and make them industry ready? So that's the sort of opportunity that we're looking at from a growth perspective. Second thing, in terms of readiness, in the last decade or so, quite a few OEMs have established their presence in India. The likes of Boeing, Airbus, Lockheed, all of them have come to India, have helped the ecosystem also grow. Today we have a lot of approved and qualified suppliers in the country, which is helping us take larger programs. And even if you see in the last 3-4 years, spend of both the OEMs, the Boeing and Airbus have increased almost 5x in the country, just the sourcing that they're doing in India. So pretty good time to be part of the India's aerospace growth story. But only things that we'll have to focus is how do we get our talent ready so that we are ready to take up this opportunity. Second thing is quite a few of the spokesmen earlier spoke about, how do we do adoption of technology that's coming. Yeah.
Yeah, which actually brings me, to my next question in terms of technologies. Over the last 2 days, we've been talking about digital manufacturing, automation, 3D printing, smart tooling. So for you as, aerospace tooling in specific, what do you feel are the emerging, technologies which will shape this industry over the next 5-10 years?
I think it's a very good question, Rashmi. See, I think evolution is part of the game, right? We'll have to continue to evolve as we move forward in our progress. So is the aerospace industry and all the other manufacturing industries evolving. First thing that comes to my mind is how do we do digital adoption? So like I told, in aerospace, the requirement in terms of documentation, traceability is very, very high. That's where digital can play a very big role. In fact, if I were to quote the session just before lunch by Mr. Saran, and where he spoke about the intelligent factories, where they were talking about fully integrated system of integrating your shop floor with MES, PLM systems, etc. How do we make the process end-to-end digital? That's something that we are very proud of doing in very early in our journey. Today, Aerospace is also a digitally native company. For us, starting from a purchase order that we receive from our customer till we deliver the tool, everything happens on a digital platform, and we are a truly paperless factory. So those are some of the initiatives that we'll have to take to do digital adoption. Another advantage that will come in, obviously, it provides a great amount of traceability. Second thing, also, it helps to reduce errors. We can build in a lot of digital poka-yoke while doing this adoption of digital technology. Second thing, in terms of future manufacturing technologies, of course, we have spoken or we have heard quite a bit of additive manufacturing as well in the past few years. I think additive manufacturing will also have a strong role to play as we move forward in this ecosystem. While I don't believe additive manufacturing is going to replace conventional machining or subtractive manufacturing, but both of them coexist. Some of the natural advantages that additive manufacturing brings in is it can help you reduce the number of parts that you're doing in a tool assembly or number of parts that you can do in an assembly as such. It can also help you cut down your new product introduction timelines. So those are some of the things that are helpful if we adopt additive manufacturing technology. Specifically talking about tooling, I think there are 2-3 things that I am looking at as new trends that are emerging. One thing is today a lot of tooling which requires high amount of wear resistance or temperature requirements are still made by Invar. If we can look at latest materials in developing some of those tooling, that will be very helpful. Second thing is a lot of our tooling ecosystem is very well versed with handling 2D drawings and making tools out of it. However, a lot of newer aircraft programs are actually moving into MBD, model-based definition, where you actually no longer have input in terms of 2D drawings or prints, but a 3D model that we'll get. So that's where in the model, even our tolerances like GD&T are embedded in the model. How do we skill our people so that we understand to extract that information and convert that into tool and develop our tooling models accordingly, something which would be very critical as we move forward.
Great. So, interestingly, I attended the ADMS event last week, and I think you were also there. So, there was a lot of talk by the PSUs, the policymakers, and, Rolls-Royce team was there. So, everyone was talking about how if India has to move up in the value chain of aerospace manufacturing, we have to shift from just structural aspects to more complex elements in aerospace, and we need to look beyond build to spec. So what's your take on that from a tooling industry perspective?
So I think just referring to the conversation from last week, I think there was a lot of conversation around how do we as a country move from build to print to build to spec. Now in a tooling space, this naturally provides an opportunity. While it's difficult to find opportunities in terms of design in component manufacturing and assembly manufacturing, but in tooling, there are a lot of opportunities. We can actually design our own tooling and then manufacture it ourselves. So, in fact, we have been executing several programs in that context for the last decade or so. So, already that level of innovation is already there in the country. How do we take it to next level is, how do we bring in some of these newer techniques like, for example, let's say if you're able to do digital assembly simulations, where, see, because when we have these very tight tolerances, there is also stacking of tolerances that happen when we assemble the tools. How do we digitally put them together and give inputs to the design partners or the OEM, saying that these are the better ways of doing it? Second thing is, a lot of the times when we start doing tooling for large aerospace programs in the country, some of these are legacy programs, where the design inputs were very, very old. But the industry has moved forward so much. How do we make changes there and go back with the recommendations to OEMs, make tooling lighter, simpler, more cost efficient? Those are the things that we'll have to work on.
Great. So I think, you've kind of answered my next question, which was around the gaps, like especially when you're working with OEs and say global, tier ones. What are some of the gaps that you see you've already addressed? But in terms of your, like an estimation, how would you rank the tooling capabilities for aerospace, as of today?
So, like I told, we have delivered already several thousands of tools which are used in global aerospace programs from the country. From that perspective, I don't see a lack in the presence of capability. However, having said that, like I told, we'll have to work on those few things where first thing that comes to my mind is certifications. Standard AS9100 certifications for manufacturing process, NADCAP approvals for your special process, ASME approvals for your GD&T tolerancing, etc. And second thing is, of course, our commitment, say-to-do ratio, all of these things have to improve for the global OEMs to get more confidence in the work that we are doing.
Got it. So in terms of, there's a lot of talk about attracting the right talent, especially the people who are passing out of the college, right? Whenever it's talked about aerospace, like, the gentleman who was there in ADMS also spoke about how aerospace is fun, right? So what are some of the things that maybe we can do to make, the aerospace tooling attractive for people to join?
Yeah. No, I think it's a very valid point. So like Dr. Kota mentioned during that session that aerospace is fun. Aerospace is truly fun. I mean, I myself have been an aeronautical engineer by training and then have been a career professional for the last 15 years in the aerospace industry. I think how do we get younger generation into aerospace? I think there's a very similar problem that even the Western economies are struggling with today. When I travel across the US and in Europe, when we talk to a lot of manufacturers, they keep telling us people don't want to become machinists. They're actually happier being a barista than becoming a machinist. Now, however, in India, we have a different kind of problem, right? We have a very large talent pool of people coming from various parts of the country. We have extremely good raw talent available in tier 1, tier 2 industries. While today a lot of the urban youngsters are very, very interested in going into new age technologies like AI, data engineering, etc. I think what we'll have to tap into is how do we get some of these unused talent from tier 1 and tier 2 cities? How do we partner with the academia in those tier 2 cities and get them to be part of the workforce and give them, of course, like some of the gentlemen spoke in the morning, how do we do a fair pay parity for them, provide world-class working conditions for them. And essentially, how do you make manufacturing cool again?
Yeah, absolutely. So, yeah, in the interest of time, my final question to you is, a lot of people from the tooling fraternity are here. A lot of people are following us on the social media. So what is your advice, for us to implement it so that we are able to meet the future needs of this sector?
So I think as we all are aware, a lot of our ecosystem comes from an automotive background. If you were to look at how does one graduate or complement their skill sets that are available from automotive industry to aerospace industry, three things that come to my mind. One thing is, of course, obtaining the relevant certifications. One thing is getting the certification. Second thing is implementing the process in true spirit that are called out in the certification. That's something that's very important. Second thing is highest level of transparency in terms of traceability and the process and materials, etc. Third thing is nurturing the talent to understand the new age technologies, like how do you get them to read the 3D models, the tolerancing requirements from there, etc. So those are the three things that I think we should focus on for them to graduate from automotive tooling to aerospace.
Awesome. So I'll give back 3 minutes and hopefully you'll catch your flight on time. Thank you so much and thank you for being a wonderful audience.
Thank you so much. Thank you, Nishant. Thank you, Tagma.
Thank you so much. May I please request you to just remain on stage. May I please request you, ma'am, to hand over a token of appreciation. Ladies and gentlemen, we are absolutely glad that we had Mr. Venkatesh joining us here for this wonderful fireside chat. Please join us in thanking him for his time.